Okay, I'm super sorry that we had to switch our stream tonight, but for some reason we could not launch the stream that we had previously identified. So what we had to do is kind of start from scratch, and that I know that's throwing everybody off, and I really apologize, but it just would not launch. So now I think we've got this one going. I'm just going to check the audio and see. Here we go. Yeah, okay. So we're working now. For some reason, the stream that I had set up in advance to schedule, it was for some reason not able to launch, and I don't know what else to do than just to start from scratch. So here we go. We're gonna go ahead and get started now. Thank you all for your patience. It's a beautiful night out tonight. I don't know if you can see if I do this. I mean, this is just a beautiful starlit night. We've got the scope rolling out there in the observatory, and you might recall that we use RASA 2600, and it's a RASA 11 and an ASI 2600 camera. We're located on the outskirts of Louisville, Kentucky, at a campus called Emerald Hills. So we use the name Emerald Hill Skies thus. And this is a Pier-Tech Tele-Station 2 observatory. It's the kind where the roof rolls off and reveals the entire night sky. And boy, is it beautiful out tonight. The telescope is mounted on an iOptron CEM70G mount. And it raises up above the roof line with that Pier-Tech 2 movable height pier. So that's kind of our setup, and what we want to try to do tonight is to be able to first go to M81. So let's take a look here. I think what we're going to try to do is connect to our mount here, and then we're going to try to do a plate solve. And what this does, you might recall, it looks through the telescope at the view and it compares it to its memory bank of star images. And if everything goes well, they'll be aligned. But if it's off a little bit, and like it is, it's going to be off here 1.72 degrees, it will synchronize the telescope using this mount to aim it precisely. It'll synchronize the telescope so that we're looking at what we want to be looking at. And what we wanted to be looking at here was M81, and you can see it right there in the center already. So now what we're going to do is go up to our sequencer, and we're going to start imaging. And what that'll do is it'll increase our exposure so that it lengthens the exposure to 20 seconds, and it'll reduce the gain to something the camera likes, about 100 gain, and that's equivalent to setting the ISO to roughly 100. That's what that simulates. And what we are going to look at here is M81. Some might call it Bode's Nebula here in the middle. And let me just look and see at our live stream. You guys have done a good job making the transition over to this. There's Dennis. I think, Dennis, you're from out in Colorado. Jesse, thanks so much. I wonder what this audio sounds like. You know, for some reason, my normal audio just wasn't working, and I had to switch microphones. I looked at my watch, and I had 4 minutes to try to bring another mic out. So I hope this is working okay. Somebody tell me what the audio is like. P. Lark, thanks for being here. Tell us where you're from, P. Lark. James from Oregon, and Spaced Out. Good to have you on. I remember we commented a couple times in the run-up to this. Goat Wave. It's really great to see you, Goat Wave. Partially cloudy skies in Denver. Thanks for being on with us tonight in Louisville, where it's supposed to be crystal clear, by the way. Angie, back from California. Thanks for being here. I think last time, Angie, you brought some cupcakes or something, if I remember right. Jesse, so sorry there in Seattle. It sounds like you've got clouds completely socked in. P-Lark, I thought it never rained in California. That must just be a song. Azray, thanks so much for encouraging. I tell you what, at 4 minutes till, it didn't feel very like a nice setup. It sounds like your mic is over-modulated. Well, we can fix that. Let's bring that down a little bit. I'm going to bring it down there and bring it down here. That's exactly the kind of thing we want to hear. Thanks for being truth to us there, Jesse. Now tell us what this sounds like. It does now, when I look at that, it looked like it's maybe a little hot, so hopefully this sounds better. I'm going to see if you can update us. James, Oregon, a little bit daylight, windy. God bless you all as well there from North Carolina. Chico, California, Pilar, good to have you aboard. Atlanta, Jen, good to have you here. Clear skies but warm. Spaced out in Maryland. Pilar, about 10 minutes worth of rain. Angela B, that wasn't me, but yes, I was tuned in last. Oh, yeah. So it wasn't you that did the cupcakes. So let's see, I'm going to go back to Jesse. When you get a chance, Jesse, tell us what this audio is like, if that's any better. So we're going to keep an eye on that. Let's take a look at our image now. What we try to do here then first is just do a reset of this big histogram there. And then we do a quick auto stretch kind of. We do a color balance. And what we're after there is just to kind of get a rough balance. But boy, it did a good job. Let's pull these darks over so we're maybe just a little bit just to the right of that peak. And then let's go into like 100%. See if we can zoom in on Bode's nebula here. It's actually a galaxy, but Bode thought it was a nebula at first. Let's kind of bring in a little bit more of the dust. And as this forms up, we've just been stacking for about 3 minutes. What we do is we plate solve images on top of one another, and that averages out all of the light forms like stars and dust and gas. It averages those out, and then what it does is it allows you to be able to pick up some of the stuff you wouldn't see if you were just looking through an eyepiece. See back here if Jesse came, still modulated but quieter. Could be the distance from your mouth to the pickup. All right, I'm going to pull a little bit more off there. Let me just make sure, because this was literally 4 minutes. Looks like that's all correct. Oh, I see the gain is too high. Let's bring that gain down. And then bring that volume up, and then let's set this volume right there. Now, Jesse, keep on telling us, because I didn't get a chance to test this over headphones. Good to have you here, Vito from Pier-Tech. This is all your stuff that we're operating on. The observatory is all you. That's basically all of your work there. You were the one who assembled this. We can try M87 there. Someone else brought donuts, Angie. You're right. It wasn't cupcakes. San Francisco Bay, no rain. Another hour before. Some EAA. Good, Birdman. Dennis, yeah, making you crave donuts. Go Giants, P-Lark. Kimberly, good to have you back. Lost connection for a few minutes. Yeah, we had to cancel the other stream. I'm so sorry about that. Birdman, yes, go Giants. Azray, sounds better. James, 100% better. Thank you so much. Boy, I tell you what, Jesse, you're the one, Jesse. We're looking to you to come. Good to have you here, Scott. We're going to look for you, Jesse, to give us the final thought about the mic. I think the gain was a little high. There's Jesse. Now better. Thank you, Jesse. Okay, so what we're looking at here is M81. This is after just 5 minutes of integration, but you can already see a lot of the, well, you're not looking at it. Let me see if I can get you back here. You can see a lot of the star forming regions here, and look at the way these stars are forming out here in these outer arms. And let's pump these mids up a little more. Look how out here you can start to see some of this dust being thrown out. And I love this galaxy M81 because it's being viewed at about a 45-degree angle. So I think you get a really good compromise of being able to see some of the structure while at the same time getting that sense that you're looking at a spiral galaxy like the one in which we live, the Milky Way. And by looking at it at a 45-degree angle like this, I'm just going to pull the dark. So I'm going to hold my shift key down while I move this. See if we can make the blacks just a little bit blacker and come up with a good compromise to boost those mids up a little more so we make this thing kind of pop out of the night. That's too much there. But we want this thing to kind of pop out of the darkness. Try to get the right mix. We've only got 6 minutes of integration. And I'm not sure. Let's do another color balance just to see if we can get our colors balanced a little better. It's just almost the stereotype, isn't it, of a grand, what you might call a grand designed spiral galaxy. And imagine being somebody, seeing this for the first time. You'd see all this dust and you're seeing it from way back. Let me zoom way back away from it. You'd kind of just, at first glance, you'd see it as a bunch of clouds. But as our telescopes got better, we began to see this is not a cloud. This is something in a spiral form. And what I like to do now is just go to Hubble and say Hubble M81, and let's go to the Hubble view of this and look at that grand design. It was German astronomer Johann Elert Bode in 1774 who first discovered this. It is one of the brightest galaxies in the night sky. It's 11.6 million light years away. It's in the constellation Ursa Major, the Big Dipper, the Great Bear. Has an apparent magnitude of 6.9, which is just on the border of naked eye. But through a pair of binoculars, you can see it as a faint patch of light. And that's kind of the way Johann Bode's telescope was. It was almost equivalent to the way our binoculars are today. So he saw it as that patch, and he called it Bode's Nebula, or somebody did down through the years. If you have a small telescope, you can see this core. And then, of course, the Hubble, this was assembled using observation of both visible and infrared. You can see the spiral arms. They wind all the way down into the nucleus, and they show a lot of these young bluish hot stars that were just formed over the past few million years. But it's just a big population of huge galaxy star formation that started maybe from an apparent age of 600 million years ago. And the bulge is much older with a lot of red stars in there. It's significantly larger than Milky Way's bulge. And it has a black hole equivalent to 70 million solar masses. In other words, 70 million times the weight and the size of our sun that's in the middle. It's about 15 times the mass of the Milky Way's central black hole. And this black hole, when you stop and think about it, would just suck in everything. And it's being matched only by the size of the galaxy. And you're seeing it live here now. This is a live view. I'm going to go down to our title, and I'm going to put here that this is M81 Bode's Nebula, a spiral galaxy. And then I'm going to go up here in Sharp Cap. I'm going to put M81 here, and look at the satellite trail that just crossed across there. But we don't care much about that. We just roll with that. With electronically-assisted astronomy, that happens sometimes. And Elon Musk is making sure that it happens more and more. But isn't that beautiful? I think I'm going to just save a screenshot of this by holding down the control key and hitting print screen. And then I'm going to just kind of pick out my region that I want to make a picture of here. And I'm going to call this M81. And let's save it in the desktop in the Sharp Cap captures. And we're going to say that it's 11 minutes and it's 33 subframes on 2022, June 17th. Welcome to the live stream, by the way. If you're just tuning in, we are in the outskirts of Louisville, Kentucky, and we're using an 11-inch RASA. A RASA stands for Roe Ackerman Schmidt Astrograph. It's a camera telescope. It's a telescope that's made for a camera. In fact, there's not even an eyepiece on it. Instead, you've got all this gear on it, on a little outrigger there. And what we have is a little rack of stuff at the base of the scope. Using this ZWO ASI2600 camera in this observatory, what we do is we get this beautiful image of this night sky brought to you through this RASA telescope. And that's a live view of the telescope there on the left side of your screen, and also a live view of the sky down below right here. And that's a photograph of the telescope there. That's not a live view of the telescope, but a live view of the sky there, and a live view of the telescope here, showing you Bode's Nebula. And at 12 minutes, we're going to call this good to go. Look at those spiral arms. It looks like something right out of the Jetsons, doesn't it? Wow! Thank you, Lord, for this beautiful picture. Let's back off a little bit because we saw another object over here, didn't we? Look at this. This is another beautiful object here. Let's go over to our planetarium software. We use Starry Night Pro here, and let's zoom in. And you can see that what we're looking here is M82, and in a way, these kind of look like a couple of eyes, don't they? Kind of like a couple of eyes looking at us. So we're looking at M82 here. Before we leave M81 altogether, let's make an observation of this and just say, let's see, the Herschel 400, yeah, that's right. We're going to say that we were using the 2600. Now, once we set that, it'll keep that. And the observing list we're going to do just real quick is the, okay, then we're going to say, wow, great view of the spiral arms throwing out all that dust. So what this does, it makes a permanent observation. Now over here in M82, we're going to do a quick observation of it. Not an ephemeris. We're going to do a quick observation here of M82, and we're going to say we couldn't help but notice it in the corner of our, or in the edge of our M81 screen. I'm just going to pull this out of our way for a minute, and let's go back to our live view here. So here's M82. Let's read for a minute about M82 because it's a very fascinating looking nebula there, isn't it? Or a very fascinating looking galaxy. M82. Oh, that's a Barrett M82 machine gun. That would not be the galaxy, right? M82 wiki. Let's go see if we can find the galaxy. Boy, what are we going to have to do here? Galaxy. There we go. Messier 82. Cigar Galaxy, starburst galaxy, approximately 12 million light years away in the constellation Ursa Major. A member of the M81 group. It's 5 times more luminous than Milky Way. Has a center 100 times more luminous. The starburst activity is thought to have been triggered by an interaction with M81. It's the closest starburst galaxy to Earth. M82 is the prototypical example of this galaxy type. That is a starburst galaxy type. And there are all kinds of supernovas that have been discovered there. M82 was also discovered by Bode in 1774. Here's a nice picture of Mr. Bode. He described it as a nebulous patch, very pale and elongated shape. And of course, in 1779, Pierre Méchain, who worked with Charles Messier, he independently rediscovered both objects and reported them to Messier, who added them to his galaxy. M82 used to be thought of as an irregular galaxy, However, later, these symmetric spiral arms were discovered in the near infrared images of M82. And let's go look then at the Hubble M82 version, and this is just, I think, an amazing galaxy. Look at this. Isn't that beautiful? Wow. So you can see the galaxy in the middle, and look at all this activity here of this starburst hydrogen stuff being thrown out. Wow. So let's look at what we're seeing here. So we are almost there, aren't we? There's the Hubble view, and here is the view through our 11-inch RASA. Let's tune out some of the light sky, make it a little bit darker so we get the full contrast. Yeah, get that forming up. And I'm just going to go look at what some of you guys are seeing. Jesse, Mike is better. James, thanks, Jesse. Mike, Jerry, welcome. So glad you're here from out in Death Valley, Southwest PA, BCCB. You must be some kind of musician. Kimberly, remember to hit the like button since you reset. That is so nice of you. Yeah. I had to reset the stream because I couldn't get the scheduled stream to work. James put those thumbs up. Jesse, so nice of you to say hit like. Kimberly from Venus, Florida. I remember you were here last time, Kimberly. We talked about that. Here we are looking at stars, and you're from Venus, and we're from Mars. Lots of old population stars in the middle. Pier-Tech, he had much darker skies back then than we have today. I think you're right. Bo did have darker skies. Jen says no doubt. Ernie, good to have you on from Buffalo. Satellite transit nucleus. Nice dart throw. Scott says, hi, Ernie. Pier-Tech. Vito says Elon Musk should be fined for pollution. That's a good idea, Vito. Jen, so beautiful. Azray. Ernie, hi, Scott. Azray, 2 for the price of 1, right? Starburst Galaxy, exactly like yours. Clouds rolled in. The falls look good tonight. Stuck here at work in Niagara Falls. Well, Niagara Falls. Scott, I was just up in Rochester, and I saw also the falls in downtown. Rochester. It's like a little miniature Niagara Falls right in Rochester. It was really cool. Scott, good. Pier-Tech looks good. M82 looks amazing. I'm with you, Ernie. JD Morris, South Carolina, very nice. Hello from a very windy, from Perth, Simon, welcome. The middle of the day. Jen says, hi, Australia. You guys are the best. So we have quite a few on the stream, about 30 here tonight, looking at. Now I'm going to change the name up here in a sharp cap, and it's going to ask me, are you sure you want to change the name? Then I go down to our title, and I'm going to say M82, and this is a starburst galaxy in Ursa Major. And let's go back to the screen, and I'm going to just use this screen snapshot again because it gives us such a close-up, nice little snapshot of the image. And you guys can see that's the snapshot we saved. So I'm just going to name it M82, and we're about, 19 minutes on this one. I guess you got to add this together with what we were doing with Bode's Nebula. 19 minutes total, 59 frames on this, and this is 2022-06-17. I'm going to save that in also in desktop sharp cap captures, and then pull in this observation here. I'm going to say, wow, the starburst core. This is this unique thing that happens. I'm going to add a new log entry here. The starburst core. You guys that have used Starry Night Pro, you know that this happens. The starburst, there we go, core amazed us. 30 of us looking simultaneously at this. We're in awe. So you are all part of this tonight. Thanks for being a part of this. I'm going to go one last look at it here. You know, it's hard to believe that this is up here all the time, isn't it? I mean, it seems so unlikely that we should be able to look up in the sky and see this, because honestly, we just don't often look at it. M81 and M82 are perhaps the most famous pair of galaxies in the sky, and both can be seen in the same low magnification field of view. Both are spiral, but M81 is nearly face-on, M82 is edge-on. The contrast offered by these two galaxies is one of the visual delights of the night sky. M81 and M82 are separated by only 150,000 light years. Tens of millions of years ago, the larger and 10 times more massive M81 passed close by its smaller neighbor M82, inducing a round of starburst formation, M82. It also led to the birth of over 100 globular clusters and disrupted the appearance of M82, so it's much of times it would be classified as an irregular galaxy instead of spiral. While quite faint and visible light, M82 is the brightest galaxy in the sky in the infrared. So let's go back one more time and realize this M82 here, M82 on the right, is the brightest galaxy in the sky in infrared. I just think this is a beautiful pair, and it sounds like you guys agree. Looking at some of the wind damage, you guys, it still looks quite spiral for you, Jesse, on the right. Look at these little nice little satellite trails. They're just really beautiful there, aren't they? All right, we're going to call this one more picture exactly seen, and then we're going to go up here in the sequencer and go to the next target. Now, what I'd like to do tonight, guys, if we could, is continue on our push a little bit with our Herschel 400 list. So to do that, we're going to open up the Herschel 400 here. And what it's going to do is, you can see it now sorting what's happening there. And we're going to just put down here the Herschel 400 list. And the Herschel 400 list is unique because it was originally made, it's a subset of objects that Herschel discovered, about 2,500 objects that he discovered. And then you had this group of astronomers down in an astronomy club down in St. Augustine, Florida. And this astronomy club in St. Augustine said, wouldn't it be cool to take a subset? So you got this Brenda Guzman Branchett and Lydell Guzman, Paul Jones, James Morrison, Peggy Taylor, and Sarah Say of the Ancient City Astronomy Club in St. Augustine. It was around 1980, so not that long ago. And they said, wouldn't it be cool to make a subset of these 2,500 galaxies and nebulae and clusters, and make it kind of a next step for people who had already done the Messier marathon, the Messier list, and would like to kind of step up to something more challenging. And so that's what they did. So we can now look at this any night. And then this guy, Stephen James O'Meara, he wrote this book, the Herschel 400 Observing Guide. And honestly, the Sky and Telescope article plus this observing guide kind of made it sort of famous. And what we can do is, on any one night, we can go through his book and pick out objects that we want to go look at, you know. And what we're doing as we go is we're also using an observed list. So the Herschel 400, we call it, when we observe it, we put it in the observed list, and that tells us what we have already observed. So here are the Herschel 400 objects we've already observed, and here are the ones that are up tonight. So what we can do is we can kind of go, I'll just show you here the screen for a minute. Here are the ones that are from our working list, and here are the ones that we've already observed. So we're making our way through this list. At any one night, we can decide, okay, it looks like NGC 6207 is high up tonight. So what we do is we go in the back of Stephen James O'Meara's book, NGC 6207, and we look that up, 6207, and it's on page 226. So then what we do is we turn to Stephen James O'Meara's book on page 226, and what he has done is he's cataloged the observing into various nights. So this is like his seventh night of observing, and he groups these Herschel list objects into various nights, and you can work your way through his book and add them to your observed list. So that's kind of what we're working on. If you guys don't mind, I think that's what we'll do. Oh my goodness, Pier-Tech, you just gave some kind of a thing. What is that? What in the world? I got to see what you're doing here. Mike, Jerry, I have a cold front moving through this weekend. Pier-Tech, good idea in June. That is chilly for us. Was 115 last week. Oh my goodness, 115 degrees. That's hot. At least I'm not the only one who watches smart TV. We had 99 this week, but Mr. Vito, Simon says, Doug, that's money. I don't know how you did that, Vito, but I tell you what, because you did that, I've got to say, you are a sponsor of tonight's program. I don't know. You just pitched in $5, and because of that, we've got to go one more time and show that you made this with your bare hands, Vito, and then we drove up to your shop, your factory in Chicago, and you helped us load these panels, and we drove your panels down here and in one day assembled this entire observatory. And I just think it's really cool the way you did this, and that pier in the middle as well. So thank you for the sponsoring. Now, Kimberly, I don't know what you've made here, but you've got some kind of object that's hopping up and down here. It looks like maybe a game controller. Kimberly, thank you so much. That $5, tell you what we're going to do with this. We are going to give this to sponsor, I know this is going to sound odd, but we're going to sponsor Ukrainian refugees coming across the border from Ukraine to escape with their lives into countries like Poland. We're going to apply this funding to help them be able to get food and water. So that's what's going to happen to this $9.99. I am not going to take this for myself, but thank you, Vito, and thank you, Kimberly, for making it possible for us to be here tonight. We are, in a way, here because of the organization, Team Expansion, that is located here at Emerald Hills. And Team Expansion has a wonderful work over there with those refugees, helping them get resettled. So this $9.99, and if anybody ever does anything else, it is also going to go toward those 11 million plus refugees now. So, okay, let's get started. We're going to go to now NGC 6207. Let's get rolling. It's a small ellipse of light near M13. So let's go there. So here we are back on the screen, and we're going to go to NGC 6207. So the first thing we're going to do is center on it, and you'll see that we're going to travel over to it. Little by little, we're going to inch over. You can watch it first in the planetarium software, as we make our way over toward, it looks like we're traveling past Draco over there into the keystone of Hercules. Look at that. And then we're going to slew the telescope. And while we do that, we'll let you watch the telescope slew over there. And you can see the telescope is, now right now, it's pretty much headed toward the North Star because we're looking at the telescope in this live view from behind it as it aims toward the North Star. And I'm just looking out of the corner of my eye, and it looks like Jesse Anderson just gave somehow $10. I don't even know how you guys are doing this. I don't have a button that I put on a website somewhere, so you guys are finding a way to do this on the YouTube channel. Goatwave says, that's really nice of you to do that, and it is, that's kind of you to encourage, but it is the reason I get up in the morning, Goatwave. So Ernie Jacobs just gave $4.99, and Goatwave just gave $10. I want you guys to know, Scout's honor with my hand up in the air, every dollar of this, I'm going to make sure it goes toward those refugees. I am not taking this for myself. And Kimberly, that's kind of you to encourage them. I am sobered by your generosity, and I want you to know that you are very kind. So thank you for pitching in. Okay, so the scope is aimed now. Look at the way the telescope is pointing almost directly up in the sky, and that goes along with our planetarium software, which is saying that NGC 6207 is 80 degrees up toward the zenith. So in other words, we're just 10 degrees from the zenith, and that does agree with that live view there. If you want to get a picture of the part of the sky where we're looking, that's a live view of the sky through our monochrome camera. It's a ZWO ASI2600MC Pro, and it really isn't aimed through a telescope. It's just aimed along the top of the scope, and that's a picture of that 178 camera. It just sits on an outrigger on top of the RASA scope. Jesse says these are super chats and are a very useful feature here on live streams. Jesse, thank you so much. I am amazed that you guys are doing this. Okay, so here we are now. We've got our, I don't know how I can keep all this stuff. There's Stephen James O'Meara's book. Let's now go over to the live view of the camera, which should be like right here. And first thing we're going to do is do our plate solve again, and that makes sure we're looking right at this object. That's going to be especially important since this is such a tiny object. And really, the RASA has a fairly wide view. This is NGC, what was it, 69? Oh boy, I lost my place. I should have set a, let's go back over here and look at our, let's make this a little bit wider. How about that? NGC 6207. NGC 6207. I'm going to put a place marker in here. So we're going to say NGC 6207 for our title. NGC 6207 in Hercules. And then let's go back to our screen. And you can see Hercules constellation there. Oh my goodness, look at these different treasures we've got here. The live view here is exactly what Stephen James O'Meara said. He said 6207 has a small ellipse of light near M13, the great globular cluster in the keystone of Hercules. And that's what you're seeing up above there. In a small telescope, it's best seen with moderate magnification and averted vision. So with our plate solving now, I'm going to change this NGC 6207. NGC 6207. And I wonder if that's it. That little dot in the middle there. So let's zoom in a little more. You think that's it? We did already plate solve this, didn't we? I'm just gonna, because I didn't see it, let's plate solve one more time just to make sure we are spot on. Pier-Tech, wow, finally science without dating sites ads. That's awesome. That's super duper. Thank you for that. Yeah, we're only 1/100th of a degree. We're going to make a 1/100th degree correction here. And now let's start our sequencer on start imaging. And you saw just one quick glance at what was in the RAM from the last image, you know, the M81, M82 pair. And what we're looking at now is a very black screen. We're waiting for the 20 seconds to pass until the first image comes in. So down here, there's the first image. And you can see that the color balance is not the same in this part of the night sky. So the first thing we're going to do is do a little bit of a color balance. We'll move our black levels over here. And kind of, you know, we're fortunate tonight. The moon is going to be extremely bright tonight, but what we've done is we've planned from 11 to 1 to be at a time when the moon isn't. And so we have absolutely jet inky black skies. Now, I don't know if you guys can see this, but I'm starting to see this object here. This is how tiny it is. We are at 100% of the RASA frame. It's an APS-C camera, the 2600MC Pro on this RASA. We're at 100% of the RASA frame. The RASA has a roughly 1.8, I forget. It's like 1.8 degrees wide frame. And that's how small this object is. So now we're going to use digital zoom to zoom in a little bit more. And we're going to just look at this faint blotch here. Let's keep playing with this and see if we can tune a little bit more stuff in here. Let's bring up our mids a little more and see what else we can bring out. Look at that faint blotch. Now, let's go over here to our planetarium software and bring up the info panel about this object. And in the description, it says absolutely nothing. This object is so nondescript that Starry Night Pro has nothing about it. But it is on the Herschel 400 list, and Stephen James O'Meara says that it's a small ellipse of light. So what would it be, NGC 6207? It's a spiral galaxy. It's a spiral galaxy, and it's 11.6 magnitude. So we're looking at something that's almost 12th magnitude. It's very dim. It's just 3 minutes wide. And keep in mind that that the sky could be divided into 180 degrees across the half that we're seeing. And then in that 180 degrees, each degree could be divided into 60 minutes. And this object is only 1/20th of 1 degree. Pier-Tech says, wow, finally sounds like Papa-Tech. Another Herschel adventure. Hello from Florida. Good to have you aboard, Papa-Tech. Pier-Tech, great planning. So kind of you. Looks like a comet changing directions. Azray Photography. Is that the one near M13? It is. Azray, good job. So we're just going to create a log entry here that says, and now I'm going to change the observing list because now we're into the Herschel 400 working list. That's going to be actually we could just use Herschel 400 all. And you can see that the session kept its name. We're going to say, let me go back to our live view. Steve O'Meara is right. This is a nondescript patch of faint light, but it's really a galaxy. A spiral galaxy, in fact. Only 3 minutes wide. Wow. So when we were making this observation, we're putting stuff into Starry Night Pro that it didn't have before. It had no description on this object. And of course, obviously, this is the first time that we've ever observed this. So we're gonna go over here and say, add this to our Herschel observed. And then we're going to go out here, and you guys remember what we do. We go to Live Sky. Because Starry Night Pro doesn't give us a handy way to remove objects from an observing list, we actually go here to Simulation Curriculum's Live Sky, which is another view of the very list that we're using here. And we edit this, and in the search, we're going to put 6207, and we're going to say, now remove this from the working list, and save that. And that way, we know that we've observed this. And one more thing I'd like to do is just see if anybody's ever written anything about this Morse 6207 wiki out on the web. Sure enough, somebody's made an entry on that. Thank you. Spiral galaxy located in a constellation. It's designated as SASC in the Galaxy Morphological Classification Scheme. It was discovered by William Herschel, of course, on the 16th of May, 1787. How in the world did he do this? Over 200 years ago. In fact, we're coming up on 250 years ago. He found this. It's about 30 million light years away, and it's near the globular cluster M13. And there are some neat views of it here. Look at that view. Oh my. Wow, is that not beautiful or what? Wow. I just got to believe this is some kind of Hubble view, but let's see if we can go back and find this credit to this. Yeah, it's by the Hubble Space Telescope. Wow. Man. Well, I would say the Hubble's doing a little bit better tonight than we are with our RASA, but on the other hand, yeah, this looks a little bit humble after seeing the Hubble view. But on the other hand, we can at least say we saw it live. I mean, that's a live view. I'm going to just put here in the title, live view of NGC. It's a live view. So you can put in your little journal. If you're doing a journal, you can put in there that you saw it live. Cocoa Bunny. What area of the planet are you viewing from? Are there any specific objects you're hoping to capture tonight? Yes. Cobo Bunny. Sorry, I might have mispronounced that. Cobo Bunny. We're viewing from the outskirts of Louisville, Kentucky in the United States. And we're working our way through the Herschel list. So what we do is we go to our planetarium software. We do a sort of the Herschel 400. We find some objects that are high up near the zenith. And then we go to Stephen James O'Meara's book. And using Stephen James O'Meara's book, we work through basically his order of looking at some that are close by each other. That's kind of our pattern. And Mike had already told, yes, that I'm outside Louisville. Thank you, Mike. Dane, you are very kind. Love this channel. Love your content. Try to join whenever I see you live. Bless you for the encouragement. You know what? We've been at this for about 1.5 years. We'll take all we can get because we're still novices at it. Ernie, good night. Clear skies. Jesse says lots of dust. Why not buy your own HST? I wish we could do that. My goodness. Dark Meta. I was here. Wow. so dark matter's been here, probably through astro travel or something. That's just so cool. So there you go. We're going to save 8 minutes view of this. And let's back off to a 100% view so we see it exactly as our RASA sees it. And let's get M13 in it. And then let's capture this to a screenshot. What I'm going to do is I'm going to use this screenshot. And I'm going to say that this is NGC 6207. And I'm also going to put a dash M13, and it's 9 minutes of integration on in 28 subframes on 2022-06-18. And I'm going to go back to the desktop. Mike, if you know, why is that not saving? I wonder why that's not saving my place. It's just a little bit of a bother. Wow, so let's say goodbye to this beautiful view of M13. Isn't that a grand view of this amazing cluster? Now, you guys that are down like Simon down in Australia, you've got your big cluster down there, the, what's it called? But this is our big cluster in the northern hemisphere. Look how beautiful that is. My goodness, that is just an amazing sight. Wow. That's just amazing. Imagine all those stars traveling together through the night. So they're going all the time, traveling together. The Hercules cluster. That's so huge and beautiful, isn't it? Let's just go out real quick just because we can do it. Let's just go out here and say M13 wiki. The Great Globular Cluster in Hercules. Several 100,000 stars. Discovered by Edmund Halley in 1714, cataloged by Charles Messier, June 1st, 1764. Into his list of objects not to mistake for comets. It's about 1/3 of the way from Vega to Arcturus. 4 bright stars in Hercules form the keystone asterism, the broad torso of the hero. And once again, you can see that if we go here, there we are. Let me back off of this for just a second. And let's bring in just another bunch of constellations so we can kind of see where we are. Here's the Little Dipper. So it's kind of behind the cup of the Little Dipper. And here's Draco the dragon. And there's Hercules. And there in Hercules, inside, is where we're looking. And this M13, isn't that a beauty? Just going to say, wow, just wow. We came here to observe NGC 6207, but we got distracted by this outlandish globular cluster that stole our attention. Wow. I mean, you just got to appreciate it, don't you? It's just huge. And look at this little faint spiral galaxy over here. Well, those are beautiful. Let's save exactly a scene. Dark matter, Emerald High. Pier-Tech. You can fit a 20-inch plane wave in the observatory. I believe it, man. You know, Vito, I just wrote you and said, I am clueless about what kind of observatory to order. Can you just think, if this were you, what would you have ordered? Knowing we have an 11-inch RASA, what would you get? And you designed the whole thing for us from the ground up. And it's perfect. It's absolutely perfect, honestly. There's no way that we could ask for anything better than this. There's plenty of room for that mount to rise up above that wall exactly as you must have envisioned. And we can still hit all the way to like 3 degrees or 2 degrees or 1 degrees or even 0 if the trees would allow it. But you can see some of the trees around the edges of the rim of the top of the observatory there when the roof rolls off. You designed this thing perfectly, and there's plenty of space in there for everything we need for it to do. So thank you for that. M13 looks great as always. Had to choose between buying a Hubble Space Telescope and a tank of gas. No, I know you don't mean that to be political, Dennis. Asray looks great and such a nice setup. You're very kind. Stormy in Perth, Jen. Sorry about that. You have a very good friend in Sydney. Man, thank you guys for joining us. When's the star party? Well, I guess it's right now. Okay, so we did 6207. We observed that. Did we did create an observation for that, didn't we? And I think we also removed it from this list, didn't we? Let's look at the info. Yeah, there's our observation for tonight. Yeah. Okay, we're off to Stephen James O'Meara's next suggested object. He suggests that you go to 6229, and sure enough, in our planetarium software, that was the next thing in order. Now, before we leave, we're going to go to our sequencer and say next target. And then here in our planetarium software, we're going to click 6229, and we're going to center on that. And there you go. You see kind of how we're moving to it. We moved outside the keystone toward Draco there. Now let's slew to it. And our telescope's not going to move very much. You can see that iOptron mount is just adjusting the telescope a little bit. While we're here, we're going to open up the info pane and just put it over there. Now we're going to go over here and go back out to full auto and go back to our screen and say, now let's plate solve this. Remember how we do this. We plate solve a few of these, and that lets us teach our mount. Live view of NGC 6229, and it is a globular cluster. I'm going to go up here in the top of Sharp Cap and change that to 6229. Looks like we changed just by 1/100th of a degree plate solving correction. And now we'll go to start imaging. Pier-Tech, you're so kind. Well, you're such a genius. And I'm not making that up either. You know, by the way, gang, I got to tell you, we paid full price for our observatory. And I'm glad we did, because that means you know that we're not saying this because this was some kind of a gift. And now we have to tell you that it was nice, because we are forever beholden to Vito. He did contribute to tonight's live stream, but we paid him full price for the observatory, and I think he gave us $1,000 off of the actual pier, you know, which was a deal because we bought both at once. But I think he'll give that to you as well. Ryan in Alberta, good to have you here. So glad the weather's better here. Thanks for joining us. Helen, no UFOs yet, but we'll keep our eye open for those. Dane, is this your main hobby or career? How do you fund this? That's actually a really good question, because we really don't fund it very well. We're funding it tonight by funding refugees in the border of Ukraine coming across. Now look at that. Is that the globular cluster that we're looking at? That's pretty striking. Let's go ahead and zoom in. Wow, and this is not yet imaging, is it? Are we live stacking? Yes, I guess we're live stacking. So that's 80 seconds. So with just 80 seconds, we're already looking at a beautiful image of this glob. Look at that. So back to your question. The way we did this, Dane, the organization I work for, because the observatory is built on their land, over time we raised money from friends through the organization to be able to build the observatory itself here. And the telescope, because it's basically sitting on the pier there, the telescope we raised money for personally, just through a lot of odd jobs and things that we do over time. It was a process, Dane, so it did take time. And we started out with an eBay telescope, saved and saved and saved and saved, and bought $700 a telescope off eBay. And little by little, God's helped us do this. It's all answered prayer, so that's the answer to that. We're going through some clouds and possible rain. Sorry to hear that this weekend. Pier-Tech, everything observed has been identified, sometimes with some difficulty. Helen, it would be interesting if you saw one. Yes. Dark Meadow wants to know if we're going to zoom into any aliens. Nah, let's don't waste our time on aliens when we could be looking at stuff like this. This is NGC 6229, and we're going to add a log entry here. And this is a globular cluster in what would you say? I'm curious, are we in, technically, is this in Draco, you think? Maybe we're still in Hercules. You know, Stephen James O'Meara probably tells us this. Yes, Hercules. It's a small but bright globular cluster about 1.5 degrees north-northwest of this star, 5.5 magnitude, 52 Hercules. It's a good object for city observers, and he tells you how to find it. It's a very small glow, but it's so condensed it's relatively bright. He used a 4-inch telescope, and he says to him, basically all he sees is just this core with a little bit of a faint halo. And Stephen James O'Meara has incredible eyesight, I guess they say, and he could see irregular form of a starfish-shaped pattern. A starfish. Let's go back and look at this. This is the live view, by the way. Who sees a starfish here? What? I think he's getting that from these stars that are out here, don't you think? Okay, let's make our observation here. And let's say in Hercules, Steve O'Meara claimed it was starfish shaped. I'm not seeing it. I'm not seeing it. Ha. But it is bright. You can tell this is a bright object. I mean, it is an f2.2 focal ratio telescope. But we had this object from hello. I mean, it, like that love song says, you had me from hello. We had this object from hello. We didn't have to actually do much stacking. So let's save it at 5 minutes and move on to the next object. This is a beautiful little cluster, isn't it? Oh, let's do one of these little things here. This little, whoops. Why am I not? Oh, because I'm not using control. Let's do this. And we're going to call it by NGC 6229. 5 minutes with 17 subframes, which is nothing on 2022-06-18. And once again, I have to manually go to desktop sharp cap captures. That's just bothering me a little bit. I got to figure out how to fix that so I don't have to go back and do that every time. Put the sequencer on next target. You know, globular clusters are unique because they are some of the older members of the objects that we're looking at tonight. And they travel together like a bunch of motorcycle riders in a gang. NGC 6217 is next in Stephen James O'Meara's book. It's a spiral galaxy in Ursa Minor. 6217. NGC 6217. A spiral in, did we say Ursa Minor? Was that right? Yeah, spiral galaxy in Ursa Minor. So we had to find, now this is the only bad part, see, since we're using Stephen James O'Meara's list. Oh, you know what I didn't do? I didn't put this 6229, add it to observed, and then over here in the live sky, we're gonna, I guess we're already editing. We're gonna look for 6229 here and take it away from the working list. Save. And that way we know that we've gone there. Now we need to find this 6217, and man, I'm just not seeing it here in a quick scan. So unfortunately what that means we're going to have to do is we're going to have to say NGC 6217 here, and we're going to say center it. So we're going to go down through Draco, coming down to Ursa Minor, and you can see this is the Little Dipper. Look, there's the North Star. And then we're going to say salute to it. So now our telescope, as you can see, our live view of the telescope that you're watching there, over there, our camera is mounted on the observatory wall so that it could look through the telescope, kind of in the North Star direction. Now you can see that the weights are up there toward the eastern sky, and the telescope is Pier West now, looking up at this part of the sky where this object is. Now look how, back in this screen view here, look how the object is on the meridian. The meridian is the line that would sort of bisect the sky into two halves. And this object is almost perfectly on the meridian, which will cause a problem for us in a second. When it gets to the meridian, our mount will basically just stop. So let's go ahead and go over to our live view here and what are we supposed to be seeing here? A spiral galaxy, right? This is the live view through the RASA telescope, and using the ZWO ASI2600. So you're looking at exactly what I'm looking at. There is no eyepiece on this telescope. We're both looking at the same thing together. And there was just a 0.03 of a degree correction there. And so you see a little bit of star movement there in that frame. Now we're going to go to start imaging. Helen says, zoom into extraterrestrials on a craft and see them waving back. That would be fun, Helen, I gotta say. Dark Meta laughed at that. Jesse said, your perseverance is a gift to us all. Jesse, I don't know, man. That's very kind of you, but I'm learning along with you, all of us together in this. Pier-Tech, how far away is that? It looks very small, but very condensed. Dark Matter, you see some other person looking back. Pier-Tech, just had to wait for you to read about it. LOL. I see no fish, only stars. I'm with you, Dark Matter. Azray, I can see it somewhat. So Azray did see the starfish. Jesse, I think the sheriff's badge was better. So starfish, okay. Azray, it's more noticeable if you Google it. It's clearly a triangular craft from the X-Files show. Dane, I'm sure this has been asked before, but what piece of equipment is highest on your wish list? Dane, I am happy to tell you I have 0 wish list now. I am completely satisfied with what I have. If it's up to me, until something breaks, I'm good. So nothing's on my wish list. Nothing. Jesse, Dark Meta, the truth was out there. Pier-Tech. Oh, Pier-Tech, you saved me. Thank you so much. Pier-Tech is noticing that I misspelled spiral. Pier-Tech, this live stream is going to be better because of you. Thank you. You guys always do that for me. Please help me out. Azray, barred spiral. Oh, look, I see it. Right there in the middle. Wow. Look at that. We're going to do a little color balancing here. We're going to move the blacks over. Keep a little bit of that sky glow, but not much, to keep that dust from completely disappearing. I'm going to hold down the shift key, and that lets you fine-tune this little bar here. You want that mottling to go away. M-O-T-T-L-I-N-G, mottling. You want that mottling to go away, and then bring up the mids. Now, this is the end of our optical zoom, but let's go in to look at the structure with our digital zoom. Okay, that's too much mottling. Holding down the shift key. Boy, got a little carried away, didn't it? Even with the shift key down. It was like I didn't have the shift key down at all. Man, this is a hard one to tune in, isn't it, folks? I just think this galaxy is fainter. I'm so glad we started out with M81 and M82 because you got to see what a nice, big, grand design galaxy looked like. But look how you're already seeing some structure. But keep in mind, this is with the digital zoom, so to speak. The optical zoom would be much more limited. But look how that bar is visible. And look at that bright star that must be in that bar. Can you guys see that? That's very tiny. Let me get our structure up here again. So this is using the optical zoom, so you're going to see some pixelation. But look at this bright star here on the right, in that bar, apparently. Unless it's just optically in front of that bar, between us and the galaxy. Let's see what Stephen James O'Meara says about it. It's a small and dim galaxy about 2.5 degrees east-northeast of 5th magnitude, Zeta Ursae Minoris. A dark sky, which is what we have tonight. Magnification, we have some, but not tons. And averted vision is needed to see it in a small telescope. I'm happy to tell you, you do not need averted vision. Averted vision is a process by which you pretend not to be looking at the object. You kind of look off away from it. Because it happens that when God made our eyes, he kind of put the optical nerve right at the back of our eye, so that if you're looking straight at the object and your photons are coming in, they're basically hitting where the optical nerve connects to the back of the eye. So what astronomers do is they kind of look away from the object, and then they try through their peripheral vision to kind of see it in the side of their view. And what Steve O'Meara is saying is, if I use averted vision, I can see this in a small telescope with my naked eye. And what I'm telling you is, I am just not going to waste my time on that. I'm going to use an 11-inch telescope and look at it like this. No offense, Stephen James O'Meara, but this is a lot more than we could see with the naked eye. Look at that barred spiral. Let's see what you guys are saying on here. Oh my. We still got a lot of alien recognition going on here. Mike was making fun of my misspelling. Oh, I wish I knew Arabic. You know, my son does read Arabic, and he would see this and he'd help us. Dark Meta says, I used to have a decent telescope, maybe 500 good quality. It's always been an obsession. Well, it's good to have you here tonight because you're seeing the same thing I am, Dark Meta. So kind of looks like a propeller. It really does. It really does, Azrae. Helen, do you think there's life out there? There could be. I wish I could read this Arabic. Yeah. Dark Meta, I think there could easily be thousands of other beings. Pier-Tech, wow. It looks like barbs. Well, I guess they are kind of like barbs, aren't they? Is that a foreground star or a supernova? That is a great question, Jesse. Let's look that up. If we exist, there's no other reason. Azrae, right on. Or it could be, we got here. Why couldn't that same thing be happening? Jose, a stone's throw away. Jose Saúl Enriquez. Gracias por venir, hermano. Let's go find out if that's a supernova, Jesse. So we're going to go to, this is NGC 6217. NGC 6217 supernova wiki. It's a barred spiral galaxy located 67 million light years away. 67 million light years away. How about that? It's in the constellation Ursa Minor. Did we get that right? Yeah. It can be located with a 4-inch or larger scope. It's 11th magnitude. It's at an inclined angle of 33 degrees. It tells a morphological classification. I can never understand these. RSB, RSBC. What does all that even mean? Has a false outer ring-like structure formed from the spiral arms. We could kind of see that. Look at this false outer ring-like structure. See? You can, if you use the optical zoom, you can kind of see that ring. It kind of looks like, if you use your imagination, like a propeller that has an outer rim on it, so to speak. A well-defined bar running across the nucleus, a partial inner ring, and moderately wound spiral arms. The nucleus is spherical, showing no indication of oblateness. What does that even mean, oblateness? The prominent bar spans an angular distance of 48 arc seconds. So this is not even 1 degree wide. This is tiny. Across the galaxy, along a position angle of such and such, a 10-inch southeast of the nucleus is at 10 seconds, southeast of the nucleus, a prominent region of star formation. It is a starburst galaxy, Jesse, which means it's undergoing a high rate of star formation. As a result, the spectrum is dominated by stellar photoionization from young hot stars. The component is less than 10 million years old, producing a blue-hued spectral continuum with absorption weak lines from elements other than hydrogen and helium. At the core of this galaxy is a low luminosity active galactic nucleus. Okay, so nothing about a supernova. So I just think that's a star that's been formed. Boy, it does look like a supernova though, doesn't it? Whoa. What is that all about? So something must have bumped in the night. So we're going to save this anyway. We had some major bumping going on there. These colors are crazy. Look at that wiki picture. Oh, that's spinning. Is that a big center with a smaller sphere near it? Si, senor. It appears to be a foreground star. Jesse thinks it's just a foreground star. Well, I don't know how we could tell, even if we had the best Hubble telescope. It would be a guess, I guess, unless you could do like a spectrum analysis, right? And if that star didn't line up with the spectrum of the galaxy, add to observing list, H400 observed, show info, and I'm going to say we saw a nice bar, a false outer ring, a star on the bar. You know, I do get a little bit miffed at simulation curriculum for not fixing this glitch. So SimCur, if you guys are listening, I just think this would be very kind, because every time we do this, star on the bar, which might be a foreground star, according to Jesse. Either way, it was cool to see something so tiny. What was it? Was it 30 arc seconds across? Is that what it said? It's pretty amazing. So now we go to the live sky. We search for 6217, remove, delete, save, and that's our workflow. Now, we finished with that. We finished the 7th night of observing. Let's go backwards to the 6th night. 6293. Now for this, it's helpful to go back to our planetarium software and go to lists and look at the H400 observed. We could do that in alphabetical order. Yeah. So NGC 6293, we've not done that. So let's do the 6th ninth. That means start with 6293. NGC 6293. NGC 6293. We're going to center on that. And then, okay, so we're moving below Draco, over past Cepheus to Cygnus the Swan, over to Delphinus and the Aquila the Eagle, past Scutum, all the way to Ophiuchus. So we're clear around now, pointed south. So let's slew there. That was just going there in the planetarium software. Uh-oh, look at that cloud. That's what that looks like up there, doesn't it? Yeah, look in your live view. See how you're scrolling past clouds? These were not supposed to be here tonight, gang. This was supposed to be an absolute stellar clear night. Look at your live view spinning around now. Do you see in your live in your, I'm sorry, your sky view, how we're picking up light in the observatory. That's not something that came with the observatory. Those are lights that we installed, and you can see them better in this picture. See those red lights around the bottom? Those are so faint, by the way. They're just little tiny LEDs. But the camera that we used here, we did a time exposure on them, so it really makes them bright. But, you know, the sky cam is kind of showing all that red brightness there. But look up in the sky. See how you can see those clouds? Those were not supposed to be here. Don't you think we ought to ask for our money back? Anyway, let's open up a little info pane on this. Now let's go over to our 2600 here. And since we traveled so much of the night sky, let's do a plate solve. And while that's the case, let's look here. NGC 6293. This is in Ophiuchus. That's spelled P-H-I-U-C-H-U-S, a globular cluster. 6293. So now we're going to go down here. This is a little bit like a 7-ring circus, isn't it? You got about 7 things going on here. This is NGC 6293, a globular cluster in Ophiuchus. Did I spell that correctly? And I'm going to go up here in the top of Sharp Cap. I'm going to put in NGC 6293. Now I'm thinking I can see this globular cluster right here in the middle. So let's go ahead and start our imaging just to get a little bit clearer picture of it. And while we do that, let's look at Steve O'Meara. It's a small but relatively obvious globular cluster. It's very condensed and can be seen with direct vision at low power under a dark sky. It's a small and tight ball of light measuring about 3 arc minutes in diameter. At 72 power, the cluster's core is bright and is surrounded by a mottled and irregular halo that seems to sizzle with dim starlight. The cluster's brightest stars shine around 14th magnitude, so they're within reach of modest-sized telescopes. And then he says, stop, don't move the telescope, your next target is nearby. Well, we'll just see about that, won't we? So we did plate solve, fortunately. Let's do a little color balance here. Move our darks over a little. Move our mids over a little. And now let's use this deep sky image annotation. And the only thing that's in our field of view right now, unless I'm zoomed in, is 6293 and 6294, but I don't see 6294. But we do have 6293, so let's zoom in here. Wow, it's a neat little cluster, isn't it? Let's do one more color balance because that's looking a little green. You know what I think we'll do is just give us one click of red and one click of blue. And another click of red and another click of blue. Maybe 2. Oh, that's too much. See how it turned blue? So this color balancing act is really just a bit of an art form, and I'm not very good at it because I'm colorblind. While that's collecting data just for a minute, let's see what's happening over here in the stream. Who sneezed and bumped the telescope? NGC 1365, the Great Bar Galaxy looks just like it. That's right, Pier-Tech. Kim, good to have you aboard. Hi, Doug. The star on the bar is a foreground star. It's also on the DSS image of NGC 6217. Thank you, Kim. 67 million light years away from us. Insane. You're right, Dark Meta. Brother T. Jose Saul Enriquez. We find it fascinating too. Emerald Skies just had a huge channel growth recently, and I'm happy to see it still growing and new people here. Very kind of you. Brother T, nice to have you here. Still watching the MR live show. I'll check this later. Take care. God bless. May we all be worthy soon. Dane, what is your favorite celestial body to check up on when you're not streaming? I would say my favorite celestial body is the one I'm looking at this moment, because to me, they're all equally beautiful and all equally challenging and all equally amazing. So it's just whatever I happen to be looking at that moment, that's my favorite. Right now, it's NGC 6293. That's my favorite. Pier-Tech. Have to head off. Thank you as always for your guide through the night skies. You're great, Pier-Tech, for stopping in. Dark Meta. Emerald, sorry my typing corrected it to skies. No problem. Lisa. Glad to have you here, Lisa. Are you seeing the large halo? Yes. Jesse, that is an artifact of the fact that our backspacing is not exactly correct yet. And the first night that it's warm and I can get, 6 hours, I'm going to work on this backspacing and correct it. I got it to within about 30%, and then it was getting cold, this was in November or December, and I just quit. I just started saying, hey, I want to do some observing. So I'll get this fixed. That's the halo you're seeing. Wow, lots of colors in these stars. Yep. Kim, hey Doug, Comet C 2017 K2 PanSTARRS is also in Ophiuchus. Might be worth a look at this comet on its one and only pass through our solar system. That's a great idea. We'll definitely try it, Kim. Boy, if it's not in Starry Night Pro, I have a hard time with it. This is at 150%, so we're well into what you might call digital zoom. Optical zoom is right there. So let's save a 4-minute image of this and go try for that comet. We've got about 15 minutes left, and if experience tells me anything, I'll need every bit of that 15 minutes to find that comet. Let's go over here to description, and it's just telling about globular clusters. Let's do a log entry and say this actually looks like a miniature M13 Hercules cluster, except it's tiny but bright. So that's what we're going to put in the observation, and then up here we're going to go add that to the observed list, and then we're going to go 6293. 6293. I'm going to delete it from our working list and save it. All right, Kim, talk comets with me. I'm going to try this, but I'm not optimistic. C/2017. Oh my goodness. It's here. Woohoo! Woohoo! This is so much easier, gang. This doesn't look like the one that you were talking about. Because you said the one that you were talking about was in Ophiuchus. This one went all the way to Coma Berenices. This must be a different PanSTARRS. AB5. Yeah, you said K2. Lisa, what is a quasar? A quasar. We'll let one of you guys look that up. I'm going to look for this comment real quick, but one of you guys please look that up and put the definition there. I think it would be a star that's gotten so bright and so powerful that it's sending out this amazing beam of X-ray radio telescope light along the electromagnetic spectrum and the radio spectrum, and it's beaming to the radio telescope, so to speak. I think that's what it would be. So Kim's saying look under the name of K2. That sounds a lot like a hill beside Mount Everest. K2. K217? No, surely not. Deep sky, planetary nebula. C/2017 K2. Oh, you're right. We got it, Kim. Thank you for your patience. Okay, so we can center on that. Back to Ophiuchus, I bet. C2017 K2. Now, the moon's just barely starting to come up now. So we might be getting just a shade of moonlight. Now let's slew to it, but I don't think you're going to see much movement in the scope. Oh, there's a little bit. We got just a little bit of clouds. Let's take a look at our sky. See those clouds along the edges? Doesn't look like the clouds are disturbing us yet. All right, so we should have slewed to it. We've got the image up. Now let's go to our camera. Oops. Oh my goodness, look. We just might be seeing it. Kim, I think this is a good call. So you got to tell us if you've been observing this, Kim, from down where you are in Australia. Dark matter. Quasar is basically a black hole eating its galaxy. Yikes. Jose, a massive and extremely remote celestial object emitting exceptionally large amounts of energy, typically having a star-like image in a telescope. Dane, was it moving? Yes, the comet would be moving, but I think very slowly. Let the scope settle down here for a second. And as soon as it settles, we're going to go ahead and do a plate stacking image stacking on this, live stacking, because this comet is just a little bit faint. Stuff around the center. Yeah, radio burst, Dark Meta says. We're still at 100%, so that comet should be here in the middle somewhere. That's it. Good call, Kim. Wow. Great call. So Kim, tell us, have you been observing this down there where you are? Saw it last night for the first time. Took an image and the comet trailed during the set of 60-second exposures. It's coming right to us, Dane says. Ah! Lisa says, I mean, amazing. Lisa, you're just the best thing to encourage someone. This is the limit of our optical. Let's do one more color balance. bring our greens down just one click. Well, that got rid of some of the comet trail though, didn't it? Let's walk over right to the left of that crest. And then let's bump up the mids a little bit. So this is not a traditional comet tail, is it? It's more like a comet coma. And I don't mean the kind of coma you get when you're asleep. The coma being kind of like this aura around it. That's just 2 minutes of integration. And we can already see that it's not a traditional object. So we're going to call this PanSTARRS C2017-K2. And we're going to put that in desktop. Where have I been putting this? Sharp Cap Captures. Fascinating stuff. Kim, thanks. That's beautiful. To think that we're seeing something. Yeah, Dane's right. We're seeing something we might never be able to see again. So this comet is in our solar system right now. Yes, maybe. Yes, likely. It's heading for its closest approach to the sun in December 2022. It's very active for such a distant object, and its hyperbolic orbit tells us it has never previously encountered the sun. Wow, Jesse says definitely. Fong Wei says, perhaps the tail is perpendicular to your camera. Yeah, that's very possible. Aiming at us. That's very cool. I'm with you guys. I think it's very cool also. I should put up here, I should say, PanSTARRS C2017. Beautiful. Let's go around under observing. We could see a large coma around the head, or maybe it was a tail on axis. Either way, huge. That's PanSTARRS C2017-K2. That's fascinating. Nice little detour there. Thanks for doing that, Kim. Wasn't very hard to locate because we had it in our planetarium software. If it had not been there, man, if only I could live long enough to notice the expansion causing objects to blip out of sight. Seriously. Good call, Jesse. All right, let's go to sequencer and say next target. and then go back to the planetarium software. Oh, did we ever? Yes, we did. Well, it looks like that might be our last object of the night. We just are like 1 minute away. Look at this coat hanger asterism right here. That's really cool. Really stands out. I wonder what star we'd have to go to be able to see that. Oh, look, it's cloud cover. Look at that. Wow. Man, just in time. We got through that comet just in time. As you can see, we've been clouded over. But, man, it's exactly time to stop anyway. Thank you for joining us tonight. If you aren't yet subscribed to Emerald Hill Skies and would like to see content like that, we would invite you to subscribe, whether you're watching this live or the recording. If you do like content like this and would like to hit thumbs up, it does raise the channel and everybody else's searches when you do that. And if you are subscribed and would like to be notified when we're doing a live stream, you can click that bell and it'll notify you when we do that. We're at emeraldhillskies.com, and of course you found us on YouTube at Emerald Hill Skies channel. And I'm just so thankful we had a good solid batch of really great friendly people all night long. You guys were just stellar. Just going to look at the final comments. Let's see. Some really nice encouragement. Dane says, you know, it boggles Dane's mind. If I look up at a star yesterday, then the next day it's gone. It happened millions of years ago. Azray, when things don't show up in the software, I just use RH and DEC to find things. Yeah, I've tried that with comets, and they do move out of the field, so I kind of love being able to, you know, track with them. But you're right. I have to look up the ephemeris. It's just kind of hard for me. Mandy, perfect timing. Yep, that's right. Right, true. If something happened and we see the light, then we really aren't seeing it for millions of years. It's inconceivable. Dane put a heart there. Azray, another great video, Doug. You're very kind. Azray, thanks for being here. Jesse, thank you, Doug. You said keep looking up, but thank you, Jesse, and thanks for the help with the audio in the beginning. We had to substitute this mic, and we would have been way off if you hadn't helped us. Thanks for that. Appreciate your encouragement, you guys. Dark Meta, Kimberly, you are so kind to encourage. Thanks to everybody who took part in this, and thanks most of all to God, who made all these cool objects, let us see that barred galaxy, made all this stuff, and evidently, from what we can tell, he just put it up there so we could find it and see it and appreciate it. So most of all, we thank him. Thanks for joining Emerald Hill Skies. I hope you'll stop back again and join us again. We try to do one live stream a week whenever it's clear and just watch the channel. We usually put out 48 hours ahead of time an announcement. And if you go to emeraldhillskies.com, we even have an email list, and you for sure get an email announcement. But we try to do that with a YouTube, whatever you call that YouTube post, I guess you could call it, in the community post there. So thanks again for being with us. We're going to close out, and we'll look forward to seeing you next time around. God bless and good night from Emerald Hills Skies.